Hi, good morning and welcome to microprocessor tutorial session. In this session, I will be discussing about the last chapter, chapter 4, about the Arduino. So to begin with, so this is sheet 4 from chapter 4. It is about Arduino. Okay, the first point about the Arduino is that it is a microcontroller. So I write in short form of microcontroller like this. So far we were discussing about 8086 microprocessor. Okay, what is the difference between microprocessor and microcontroller? We know that in microprocessor you have ALU and the control unit in a single chip. Okay, this is your microprocessor, but it needs to interface with IO system, and it need to interface with the memory. Okay, but in microcontroller, a single chip, okay, you will have microprocessor and all input outputs plus memory also. Now, what is Arduino? Arduino is a hardware as well as software platform. It is hardware as well as software platform that helps people to make digital devices. Okay, and it's a microcontroller, very small, very low power computer. So microcontrollers generally has CPU and memory, and it will have long-term memory, right? And it has input outputs, GPIO pins, etc. But this long-term memory is of very small size. Generally, a typical example may be a 2 kilobytes. It is not a. That's why these microcontrollers are very cheap or inexpensive. They're cheap and inexpensive because of its low storage. They are capable of running only one program at a time. And input output pins, general purpose input output pins, are used to control other electronics or circuitry from our program. So let us talk about some history of Arduino. That something happening or not? Okay, it's good. Yeah, generally in the days before 2003, just if you want to just blink an LED, just to blink a light, to blink an LED, using microcontroller, you need to download multiple gigabyte of IDE integrated development environment and spend a lot of hours in configuring it to compile and upload to your exact microcontroller. So this process was absolutely a pain. So just for blinking an LED, it is taking a lot of time, okay, and it is taking a lot of memory for software, okay, and it's a difficult process. It was very difficult. So what happens in 2003, Hernando Barragan created a software called wiring. Then in 2005, Massimo Banzi and David Tactiles. Okay, they created Arduino based on this wiring software. So in 2003, they have created a wiring software, and in 2005, Arduino is created based on this wiring software. Okay, it is created in Interactive Design Institute, Iberia, in Iberia, Italy. The idea was they wanted a device that was simple, easy to connect to various things such as relays, motors, and sensors, and easy to program, and at the same time, it should be inexpensive. So they come up with a solution that for this they have selected a family of microprocessor, AVR family of microprocessor, which is of 8 microcontroller devices from Atmel. Taken it from Atmel. And after that, they designed a self-contained circuit board with easy-to-use connections, and they wrote, bootloaders, firmwares for microcontroller, and packed all in a simple IDE. So that's why these used programs, they call it as sketches. You'll see that the program when we create in Arduino, they called as the sketches. The result was Arduino. Okay. So every Arduino board, they have Arduino runtime. Here, every Arduino board, they have Arduino runtime. It's called as AVG GCC library. Chooses this. It has an IDE, integrated development environment. It is freely available, and it has some onboard bootloaders and firmwares. Okay. And firmwares. Let me save it. So I will go to the next slide. Now let us work out with how this Arduino board look likes. Okay, and we'll write a simple Arduino program for blinking an LED, and we'll see that how easy it is in Arduino. As I've told you that blinking an LED previously was very tough, and blinking LED with Arduino is it's very easy. So for that, I'll show you a simple way of doing that. So I will because if I show you on the software, this is an online class, so I cannot show you the board, and also that's why I'm using a virtual simulator. Okay, so for this you have to do the following steps. Go to this site called tinkercad.com. Okay, and this is a free tool for 3D modeling and also for Arduino circuit simulators. So you have to first sign up, create your account. Okay, after creating an account, we'll go to circuits, and here you'll find a lot of Arduino circuits, and I'll show you how to write an hello world program in this. Okay, so Let me share screen with you. So I hope the screen is visible to you. Okay. So here you have to go to tinker.com. Okay, just type the name of this site as tinkercat.com and log into this. After you log in, you will find this with your name, the account. In this, you can go to circuits, click on the circuits. When you click on this circuits, it will give you any create new circuit. Just click on this create new circuit. I will show you how to write an Arduino program from scratch. Okay, the first point is before I show you, I will show you the board. Now here you will find this, all basic components. So here I can search for Arduino. Okay, let us take this Arduino UNO. Yeah. So now you can just place it at anywhere. Now you can observe it. Yeah, this is your Arduino UNO board. Let me give you some introduction about this board. Yeah. Okay. So yeah, here in this you see. Do you see this? This is an LED. Okay. This is an LED. It's a light emitting diode, which is electrically connected to this pin 13. Okay, this LED is connected to pin 13 of this board. And to give Arduino power and send our compiled programs to this microcontroller, we connect this USB. This USB is connected at one end to this board, and the another part of the wire is connected to your laptop or your computer. Okay. Then you have to open the Arduino. So from that you have to select file, okay, and go to new fresh sketch. So here what you will do is, here I can just click on this code. This will give me a new sketch. So I'll just go for only text sketch, click on continue. This will give you the first sketch. Okay. By default, it has given me the blinking of LED program. Okay. So is the screen visible, all of you? Okay. So now here you will find two functions: void setup. Okay, pin mode is 13, output void loop, and there is something written. I'll just come to it. So you will find two methods here. One is setup and another is loop. So everything that you want to write inside setup, that will run exactly once when the when this Arduino board boots up. Okay. So whatever you write in this setup code, it will be executed exactly once at the time of your Arduino board setup. Once your Arduino board is on and it is set up, then whatever you write inside this loop, it gets executed again and again forever as long as your microcontroller is powered on. Okay. So every Arduino program has one and only one setup and loop function. This is very important. Every Arduino program will have only one setup and one loop function. Setup will be executed only once and loop will be executed as many number of times as possible. Not possible, as many number of times the Arduino board is powered on. Even if there is nothing written inside this function, this will be called and nothing will be executed. But this function will be called in empty fashion itself. Okay. Now to blink an LED, we first need to tell an Arduino that we control pin 13. As I have told you that this LED is electrically connected with pin 13. Okay. So we need to control this pin 13 voltage using code. Is nothing but setting the pin 13 as an output. Okay, so you have seen one function called pin mode. So here we are setting the mode of pin. This is a function which we are calling. So we are connecting this pin 13 as an output. Okay, so in pin setup we write pin mode 13 comma output. We went to, so what happens, this output we want pin 13 in output mode. What is the meaning of this line? We want this pin 13 to be in output mode. Okay, and this is your first parameter, the pin number we are writing, and in which mode you want to treat this pin as. Okay, you want it as input or output. And second is pin mode is a special Arduino function which we can call to set the mode of a pin. So to set the mode of a pin, we use pin mode as a function. Okay. Next comes the loop function. So in the loop function, we are writing this code called digital write. Okay. It tells Arduino that we want to write high to pin 13. Okay. Digital write is saying that we want to write high to pin 13, which causes in Arduino pin 13 to go from 0 volt to 5 volt. So this pin 13, when I write high, it goes from 0 volt to 5 volts, which is enough to light the LED. Then after that, we do delay. Microcontroller do nothing for this 1000 milliseconds, which is equivalent to 1 second. We are introducing delay. After this 1 second, again I want to off the LED by changing its voltage from 5 volt to 0 volt. This I can do again using digital write 13 comma low. So from 5 volt it comes to low, and again I'm doing nothing, I'm waiting for 1 second. Okay, so this is how. Now we have to tell the Arduino that which board we are using and on which port. Okay, for that you need to go to tools and select Arduino, and and port you can use some COM4, then save it, compile automatically, it will compile and send to the microcontroller board. Okay, but here I'm using this simulator, so here I will just click on start simulation. Okay, see, I just start simulating, and when you might have observed, you see light is blinking for 1 second and off for 1 second, on and off. You see it's blinking. I can introduce more delay also. I can just stop the simulation, and instead of blinking for 1 second, I will make it for 3 seconds. Okay, so I'll just increase the delay, and again I just start the simulation. So when I start the simulation, you might be seeing that okay, LED is blinking for 3 seconds, and again it will go off for 3 seconds. Okay, on for 3 seconds and off for 3 seconds. So this LED is blinking. So I've introduced the delay. Now you might have observed that how easy it is in doing with Arduino. Okay, it's very easy to do with the Arduino. So you see when I powered it on, this is powered on, and a loop is getting executed as long as your board is turned on. Another important thing is microcontroller are designed to run the program if they are not connected to computer also. It means when once you uploaded it and you just remove this cable from the computer and try to give it from the battery or from your power bank, okay, it will start executing because the code is not downloaded onto this board and the code is running as long as your board is powered on. Okay. So I will just stop the simulation. Now, similarly, you have many pins. Okay, there is one more pin called pin 0 and pin 1, and it is written as RX and TX. This is like transmitter, and this is a receiver. What is the use of this pin? See, these pins can generally be used for debugging. If the program is not working as your expectation, then we need to find out what place of code is causing a problem and hopefully fix it. We can call this process as debugging. So in most programming languages, we can do it very easily by displaying messages to monitor. Okay, we can just display a message onto the monitor, but Arduino has no easy way to connect to a monitor. Okay, which makes debugging quite difficult. So, however, there are several ways to debug. One of them is using serial monitor. Okay, might be seen here the serial monitor. When I show you the code, this is the one of the ways to use this serial monitor for debugging purposes. I will show you how to use this. Okay, so for that, you need to understand what are these pins, transmitter and receiver is. See, another important point is if you want to send our program from your laptop or personal computer to the Arduino, use the USB connection of Arduino also, okay, which allows us to send characters from our program to PC. I repeat that in addition to send our program from PC to Arduino, okay, the USB connection of this Arduino allows us to send characters from our program to PC to be displayed in a special console. Okay, so this is very useful to track bugs. Okay, this is called a serial communication, a universal asynchronous receiver transmitter. Okay, on a microcontroller. So this microcontroller uses 5 volts for logic 1 and 0 volts for logic 0. Okay, every message you sent using UART, universal asynchronous receiver transmission mode, is 8 bits of data or 1 byte. Okay, messages sent from Arduino to PC. So far we can send from PC to Arduino, it's okay, but from Arduino to PC also we can send messages. Okay, how can you send these messages from the PC? They are sent from this pin 1 and this pin 0 and pin 1. Pin 1 is transmitter, pin 0 as receiver. They are directly connected to our laptop or our computer. Actually, they are connected to a chip on the board. This chip on the board, okay, which is, you see here also you'll see transmitter and receiver. Transmitter. Actually, these are connected to this chip on the board, transmitter and receiver, which acts as a USB serial translator. Okay, this will act as a USB serial translator. So I'll just show you now a simple program in which we will send welcome to microprocessor tutorial. Okay, this message I want to send in the serial monitor. Let us see how to do that now. So for that, here the first thing what you have to do is in the setup mode, you have to write, you have to mention that it's communication speed by using an object called serial dot begin. Okay, 9600 is the constant value. Serial is an object, okay, and 9600. What is this begin? Begin is a member function inside this object. So this tells serial object to do initialization steps that need to happen in order to send and receive data to pin 0 and pin 1. Okay. So I have written this. Now in the loop, I just remove all this code. And here I will just write serial dot println. Serial is the same object and begin is another member function which is which allows to transmit letters and numbers. Okay. So here I write welcome to microprocessor lab tutorial. So after this, I have to put this semicolon. This is very important. If you miss the semicolon, it will give you an error. Okay. So now see here, when I run this code, let us see what happens. Okay, to show you that the setup executes only once and the loop gets executed every time every time forever till the board is powered on. So here I will write also println serial dot println, and here I will write some message. I am setup function. Setup function. And welcome to tutorials lab. This is loop. Okay, loop function. So this is what I have written. And another important thing is because it will come so fast so that we cannot see the difference, I will give some delay here. Okay, delay of 2 seconds I will give here. First it will print I am setup function. It will give delay of 2 seconds. After the delay, it will print welcome to the microprocessor tutorial or lab, and I'm in loop function. After this, again, I want to give a delay of 1 second. Okay. So now let us see if I run this code. I just started simulating it, and you will observe that. Yeah, you see, I am setup function. It is printed only once, and welcome to microprocessor tutorial lab I'm in loop function. Okay, you see it was executed only once. Setup was executed only once and loop is executing every time. So I just stop the simulation. We can do one more variation, that there is one more thing called print ln and print. There are two functions. Okay, so what is the use? Print ln will print it and go to the next line. Okay, and print will print only on the same line. So to show the difference, I can just show you how to do that. So I'll write, you see here, if suppose if I have written only print ln, instead of print ln, I just write print. You see it will start printing on the same line. The first setup gets called, the am setup function, and then welcome to tutorial lab. And again, you see it is typing on the same line. It is not going to the next line. It's typing in the same line. So this is the problem, right? So that's why if you want to print everything on the next line, so we will give print ln. You write print ln, then you see it will print onto the next line. See, and setup function, you see, it's called the next line. It is printing in the next line. So this is just introduction to the Arduino. Okay, and you have a lot to learn because there are many things, analog pins, digital pins, and a lot of projects can be done using this skills. But for that, you need to learn this programming. I hope this is sufficient for the chapter 4 as far as your chapter is concerned. Okay, so I'll be stopping here, and by this we have completed the syllabus as well. Okay? So if you have any questions, you can email me on salman@kku.edu.sa. Thank you.